Hi, are we back? Looks like we're back on YouTube and Twitch. Cool. Well, sorry about that. If you were here on the previous attempt at streaming, I was sidelined by a problem with the video capture card that required a bunch of rebooting and fussing around. But I think we're back. So anyway, I'll briefly read you the introduction just in case, I like to provide a bit of an intro for these streams for folks who are tuning in the archives, just so that within the first few seconds you know what to expect. So this is actually going to be a bit of a, another kind of separate little self-contained side project. Bit of a break from the winch streams for Tuco Flyer, which have been quite exciting, but we'll be using that on stream a bit for sure. Anyway, mostly I want to, on this stream, try to play with some neon and high voltage and perhaps make some kind of Rube Goldberg machine together in order to enter this flashing light prize contest in 2018. So it's a thing that I've been wanting to do for a while, but I kept putting it off because the robot project was so interesting. So I think it's time to try to get back to it before we are running too close to the deadline there. So, how are we doing? Are we back on the stream? It seems like the bits are coming in. Sorry about that interruption. I'm getting the robot booted up again too. Cool. Yeah, thanks for sticking with it. This is a problem I've had before, but I'm not quite sure what causes it or how to prevent it. Something just ends up overwriting the configuration in one of the Blackmagic capture cards, such that whereas it usually has 4 separate inputs, some kind of configuration gets lost, and it ends up thinking that instead of 4 inputs, it should have like 3 inputs and 1 output or something. And so then that clashes with my OBS configuration, which is setting up, 4 separate inputs. And then something inevitably breaks that ends up like crashing the driver until I reboot. So it was just kind of a mess. But I think we're back. Tuco is pretty chill on the couch here. And now you've got the regular view, so that's good. Yeah, also while I was tidying up the shop, I found that little mirror I was looking for, so I could actually show you what the robot sees in the mirror if I hold that up, which I thought might be interesting. You might notice the flashing on the LEDs. That is completely not intentional right now. That's a bug, which one of my tasks actually has been, I've been meaning to actually set up a proper bug tracker for this project, because I think it's about that time. And yeah, that would be one of the bugs. I think it's just a signal integrity problem because of the 3.3 volt data that I'm shoving into these 5 volt LEDs, and I'm usually getting away with it, but maybe not quite here. Oh yeah, Alex says we should start tracking Tuco's breathing rate. Yeah, actually, if that would be an interesting computer vision plugin, wouldn't it? How would that work? I have a feeling we could do something in the frequency domain with the motion vectors we get out of dense optical flow, which is something I would kind of like to do anyway. One thing I've been thinking about adding to the computer vision suite that we've got running here is to do dense optical flow, maybe just around the area that the region of interest is set to. And that's, I would still like to maybe replace the rectangle tracking algorithm entirely, because it's all right, but it doesn't work that well, and it's really resource intensive because it doesn't run on the GPU at all. It's spending pretty much an entire CPU core to run that rectangle tracker algorithm. So yeah. And actually that brings up a good point, is that speaking of tracking data, I should show off the latest state of some of these data dashboards. That's one of those things I've been putting together a bit off stream. So I might have mentioned on this bot project that it's, it has all this internal data that it deals with at a fairly fast rate coming over the network from all the little robot microcontrollers. And that's actually like 250 hertz. But the bot server now has the ability to take that data and downsample it to only like 100 hertz and then store that in this open source time series database called InfluxDB. And I've tried a couple of different tools to visualize that. So far I've been mostly using Grafana, but I've also tried Chronograph, which is InfluxDB's own solution, whereas Grafana is kind of a more established open source project that supports InfluxDB along with other backends. So, let's see. That's the debug view again, but I did actually have this view. Let's go here. So yeah, this has been fun. The robot server now dumps stats in here in kind of large batches, but with that 100 hertz or so resolution. And I've been experimenting with putting together dashboards that show different aspects of it. James says, are those data public? Well, clarify what you mean by that. If you're asking if I mind that you're seeing it, well, no, you're welcome to see the numbers. The data is public in that sense. But if you're asking whether I'm just going to like open a port from the outside internet into my InfluxDB instance, the answer is probably no. Maybe I make that a value add for my patrons, but it seems like risky from both the security and uptime point of view to just open that to the internet. I mean, it would be very easy for somebody to just overwhelm my InfluxDB with large queries, for example. It would be like extremely easy to DDoS. So I can't really just like open the database to the public. It'd be like opening my MySQL instance to the public. Like, I would like people to have access to the data, but just from a hosting logistics point of view, I can't quite do that. And if I were to host it externally, then it would have the same kind of problems. Like, it would still be kind of expensive to just allow arbitrary access to it, except now instead of running it on my own cheap hardware and relatively cheap internet access, I would be paying someone to host it in a data center, and it would literally be like $1,500 a month. Like, it would be pretty expensive if I wanted something that was just like arbitrary high bandwidth InfluxDB access. So that said, somebody already asked me this question on Twitter, and I was looking into other options, and there's like a way to share graphs publicly on Grafana, which doesn't actually host. Well, so normally the way this works is that Grafana itself is just the front end. So I was running it in Docker before last time you saw this. Right now it's just like installed locally on a Linux box here. But it's not the same Linux box that's running the database or that's doing any of the rest of this work. It's just like a random machine. Whereas the database itself is running elsewhere. And so the browser here actually ends up kind of doing the integration where Grafana stores the layouts and provides like users and, dashboards and just like, it's like basically a web app. Like, it stores all that data on behalf of the client or on behalf of the user. But the actual graphs are done, the way I understand it, entirely client-side. Like, there's just JavaScript that implements these dynamic graphs, and then there's JavaScript running the query. And the way that this normally works, like, it's not really designed to just like put this on a public internet site. Like, it's designed for like corporate intranets and stuff like that. So you'd give your coworkers access to the database probably, but you wouldn't just give like random people on the internet access to the database. What you would give random people on the internet access to is a snapshot of the data. So that's what that feature lets you do. You can just hit this thing, share dashboard, and you can give people a link, which only works if you're actually on the LAN and you're logged in. Actually, maybe it doesn't require logging in, because I think that's what the snapshot is, or... Yeah, that's the difference between a link and a snapshot, I think. A link is just literally like a web URL to this page, which requires you to be logged in, and then it'll go fetch the data from the database. You can configure it to either go directly from the JavaScript in the client to the database, or you can have it proxy through the Grafana server, which is their recommended option because it lets them, not reveal the database username and password to the JavaScript client. So that's the way it's set up, but it still means that the client can just execute arbitrary queries, I think. So you wouldn't want that to just be accessible from the internet. But if I go over to Snapshot, then this is specifically for publicly sharing the data, and it's not sharing database access, it's just running the query, and then it's like a paste bin for the results of the query, basically. And that seems nice. So I could do a local snapshot, which seems to work, and this is useful if you're on my LAN. This would also be maybe an okay thing to share, if I was running Grafana on a public port but just didn't give out any credentials for it. I could maybe share these safely, but that would only work in a world in which Grafana has no bugs, so I'd want to isolate that pretty well. What seems a little more promising even is this option to publish it to this other snapshot.raintank.io service, which is, it seems to be an open source way to just share this stuff publicly. Unfortunately, that doesn't seem to work for me. As far as I can tell, it's because I'm running the beta version of Grafana, and if I was running the latest stable Grafana, I think this would work. So I'll either wait for them to upgrade Raintank, or I'll go back to the stable Grafana. I don't actually know what the differences are. I think it might have actually been pretty significant. I think a lot of this, new grid system where you can just move stuff around is new. It's a little bit infuriating because look at that giant mess I just made, and sometimes it's easy to put it back, sometimes it isn't. I'm almost still getting used to the grid system. But anyway, this is nice. This is just the last hour. I think I've had most of this running overnight. Let's see what I can get if I ask for the last 24 hours. It's still reloading a lot of these graphs because I think it's actually going to ask, or it's going to be loading quite a lot of data for this. I still haven't set up anything to automatically downsample the data, so it's still storing this at 100 hertz. Jim says they were thinking about maybe having a low sample rate download of while this stream was running, that was the data. Yeah, I mean, I definitely think there's some value in having some data associated with the stream, for example. I was just realizing I'm putting my hand next to the antenna for this belt pack, so sorry if that was causing mic interference. I think maybe a good compromise for that at the moment is going to be to have some good on-screen display telemetry for the robot. I've already got a little display that shows the current gimbal position, the angles relative to the limits, and I might just have little displays for that kind of data. That would definitely be nice for the winch forces, for example. So for example, what would be just while this stream was going, just the last little bit of this, right? I haven't actually been moving it around much on the stream. Some of this data is a bit useful longer term, it is nice seeing how the chords settle a bit, and some of these force changes, actually I'm not quite sure how to explain. In this time period, it's actually kind of interesting. I don't know why the forces kind of went up and then back down. I mean, for all I know, this could have been the building changing shape very slightly as the sun started to hit the side of it. The thermometer is kind of interesting too. There's the thermometer in the IMU, which rounds everything to an integer degrees Celsius, so it's not the greatest resolution, but you can still actually see some good trends, like this. Whoops. So yeah, I think this might be a little more useful immediately for things like debugging the wobble in the gimbal. So for example, having the accelerometer data and all the motion control data together should be really nice. I'm looking forward to digging into that. This is just kind of a teaser. I'm not going to go too deep into this on the stream because I want to get into the neon, but I had to at least give a bit of a status update here. that load? Oh, it did load. Okay, cool. So yeah, those are the force sensors. I think that was like the last time I just moved the winch around. So ideally I want to highlight the region starting from whenever I hit the controls and ending like when the accelerometer settled, and to just kind of take a look at that whole thing. The accelerometer is so tiny in this graph, but I can just hover over that and hit V to magnify it. So I may have some other dashboards that are more customized for this particular use case, because this just kind of is a kitchen sink right now. Yeah, but this is great. Like, you can see the oscillation pretty clearly in the load cells too. And so a lot of this is just us doing a kind of bad job at the end of the motion here, transitioning from the smooth motion back into a steady state and letting all the PID loops settle out. Some of that is the PID loop tuning, some of it is probably just bugs, some of it is definitely the algorithm that tries to keep the winches from going too slack. So like when this started hitting this limit right here was probably when it all started to go a little bit bad. But you can see some of that was oscillating even a bit before that point. Pretty much there were a few things I like about Grafana so far relative to Chronograph, but I'd be interested to hear more, like if you have experience with either of these tools, like what you think the trade-offs would be in this circumstance. But so far, I've noticed that I really like having these arrows and the zoom control to navigate with the data. That's something I miss with Chronograph, because with Chronograph, I could zoom in and out, and that would let me redo the query, but then there were some other navigational controls that only seemed to just replot the existing data without redoing the query. So if I zoomed in, and then I want to see like, oh, well, what happened right before that point, or what right after that point, I can't just like scoot the range over like I can with these, or at least I don't know how to do that if you can. So we'll dig quite a bit deeper into this data in a little while, but just want to show a preview of what I'm actually collecting at this point and what the bot is doing. There's just a lot of different stuff coming together. So we've got data from the actual winches. These are the force sensors for all 4 winches overlaid, so you can kind of see the pattern of how the winch is moving, or how the system of winches are moving in this graph, which is why it's so big. Then there's a graph that shows the actual manual controls, like these are the joystick inputs, basically. And so if I zoom way into an actual movement, you can see here I'm switching modes, and then right here I'm in manual flyer mode, and I'm moving the camera, and then I switch to halt mode. So just that. Some of the very next stuff we're going to get into is dealing with this LiDAR data, which should be really cool. This trace 0 is this is the LiDAR sensor that's getting the approximate distance to the thing that the camera's aimed at. And then these other 3 traces are aimed downward, so that gives an estimate of the height of the robot roughly. There's some math we're going to do to that to try to get a better estimate of the height given the angle that the robot is sitting at. But that's going to be the main input for figuring out the height for sure. These analog sensors are interesting. You can get a bit of a sense of what's going on from this. Like, you can tell when the flyer moves and when something's in its vicinity, but there's a lot of work that needs to go into just like fixing up the hardware so that these are giving us better data. These are just not aimed very well right now, and so there's a future project in building some aiming brackets and calibrating these sensors so that we can get, this is the data we're eventually going to be able to use for collision avoidance. And this is a sensor I honestly put in there just for fun, but we might be able to use it for collision avoidance too. It's It's basically a radar proximity sensor, kind of like what you'd see in some types of automatic doors in buildings. So this is just sending like, I think like a 10 gigahertz signal out in the immediate vicinity and looking for phase changes in the reflections. And then this number you're seeing is just, I'm counting the rate of those pulses that the module is emitting back to the microcontroller. I've also got stats from the Gimbal controller, from the computer vision. The rectangle tracker is kind of interesting here. As you can see, this orange trace is showing the number of frames since the rectangle tracker was reset. So anytime this number is low, we're actually doing a good job of tracking Tuco or something else that we're actively tracking. So like if I look at the last hour, right here was when the stream was rebooting, sorry. But right here it's actually tracking really nicely. So the orange trace is low, and this is showing, it's basically like a measure of how much contrast is in the tracking rectangle. Right now that's actually really good too. It's like around 20. I was tracking like a blank white rectangle a while ago and that was very low. Yeah, the dashboard's fun. So, I've got a few other fun dashboards too. I've just been playing with getting my network here set up with Grafana. And I've tried putting together my own little dashboard. I'm curious what it looks like during a stream because I haven't seen this yet. No CPU utilization on color burst. That's interesting. This is calculated according to CPU idle time. I wonder if it's breaking because the CPU has no idle time, because it's certainly got plenty of usage right now. And I can keep track of my recording disks and the NAS and the Wi-Fi. All them megabits. Yeah, so this is fun. I think the monitoring service is just dead on this machine. I should get that fixed. I probably just didn't set it to start on boot when I reset. Maybe I can fix that really quick. So then there's actually a second dashboard, which a lot of you might have seen, which is the real-time dashboard. And that one has a lot more like custom stuff in it, which is why it doesn't look nearly as polished. Whereas this is mostly, I'm just standing on the shoulders of giant existing open source projects. Oh yeah, why is Telegraph stopped? It's supposed to be automatic start on this computer. Weird. Seems to be running now. Oh, that's a good question. Ellie asks if that's SNMP by chance. There is a little bit of SNMP involved at this point, but the main thing that's going on here is InfluxDB. So the host usage here is coming over from a data collection daemon called Telegraph, which is kind of the main data collection daemon that the InfluxDB folks are recommending and working on. Are we getting data now? Oh yeah, alright, cool, I fixed it. We're still plenty busy. I just thought metrics for the actual streaming machine during a stream might actually be useful, so that's why I bothered fixing it just now. Yeah, so the overall thing is InfluxDB is in the core. I should just draw a little block diagram for this thing, since people seem to be interested in it. Let's see, so there we have a bot. let's say this is my web client. So you can connect directly. This is the web front end that we've been writing in React. There's also a central data store, which you're supposed to draw like a cylinder, because disks used to kind of look like that, I guess. And this is InfluxDB. And this is running on a separate machine. The bot has its own connection to InfluxDB, where it also shoves data. And then we also have data collection daemons running in various places, and that's the local Telegraph instance. So I'll just draw these as like a little telly. There's also a Telegraph over there. There's a bunch of others elsewhere on the network for these random hosts. And there's also a Grafana. Which also has its own little telegraph. Grafana is also connected to InfluxDB. The client connects to Grafana. The client also connects through Grafana to InfluxDB, because that kind of Grafana contains kind of a proxy that basically lets the client talk directly to InfluxDB just without supplying its own credentials. And this actually does most of what you're seeing. So the page specifically for Tuco Flyer is coming from, served through Grafana, through InfluxDB, but from the data that was put there by the bot daemon. You can also get that data at a higher data rate by connecting a client directly to the bot daemon using a different set of tools. So far, that's pretty different, and I don't see that much of a reason to unify them because they have fairly different goals at this point. But the bridge between those two worlds is pretty lightweight. That's that metrics.rs Rust file that we've looked at a few times. The one place where SNMP comes in actually is I've got a router over here, and one of the Telegraph instances also pokes at SNMP from the router, so like that would be like some ugly line that way, I guess. So SNMP is a really old school management protocol. It's based on this. You request like the data that's associated with a long string of numbers. It's like a key value store, but it's like kind of awful. But somebody already had a nicely pre-made configuration that makes dashboards out of the SNMP data that you can, so it was like a Telegraph config file that collects the proper values from the router, and then a Grafana dashboard that visualizes that collected data in an interesting way. So somebody had already made a package like that for my particular router, which was nice. So yeah, that's what you get over here. This is the Ubiquiti Edge router thing. So yeah, this is pretty neat actually. It isn't quite exactly the metrics that I need. Like for example, this doesn't seem to show any of the per host stats, which would be kind of cool, because this router does actually collect stats like per network host. So I can see like, oh, this computer was doing a backup, or this computer is just like hammering its NTP server or whatever's going on, and that's like nice to know. And like right now I can get that info if I log into the router, but it'd be nice if I could aggregate that elsewhere. But this does show like all the traffic info and then just like local CPU usage and performance metrics, which are kind of nice. I don't know why the CPU usage is so high. I think it's mostly the metrics that it's collecting, but I should investigate that. And it doesn't seem to actually be leaking memory. It just kind of wavers up and down a lot. But yeah, this is all over SNMP. The CPU usage might also be partly because I'm querying SNMP so much, but you know. Oh, that's a good question. Actually, a couple of good questions from YouTube chat. Sorry, I'm a little behind. So, Vin says nice graphs, which isn't a question, but yeah, I agree. I have to reiterate that like these are not my doing at all. This is all Grafana, which is an existing open source project, which does a pretty good job of making these graphs look pretty, even if you just like create them with defaults. It just picks colors and such. So that's pretty nice. The other thing I've been mentioning is this is the dashboard that I wrote, which is this thing, which you probably have seen. this has the advantage of being real time. So like I can tick over to this winch page, and it just shows you exactly what the server is dealing with right now. So for example, if I was to drive the robot around, you could just see that move pretty much in real time. Like you might be able to hear the winches. And it's like pretty much right in lockstep with the website, so that's nice. But once it scrolls off the side of the page, it's lost. Like you cannot request historical data from this service. Like I can imagine some converged world where either the InfluxDB stuff is fast enough to do this kind of real-time update, or the client can use the same front end both for queried data or for real-time data. But from where I'm standing right now, that seems like a ton of work that is not actually that helpful. So for now we have two separate systems. And there's a somewhat different way of adding stuff to this graph. This is based on a data model, which is it always has access to both all the data coming from the microcontrollers and all the data generated by the local control loop. So it's very featureful. You can just like graph any of this stuff just by writing a little bit of HTML. But it also relies on having this like couple of megabyte per second fire hose of WebSocket data. So it's hard to use on Wi-Fi. It's definitely not something you'd want to ship across the internet. And then, so it looks like Linkanu is asking what the web page tools are called. So the front end here is called Grafana. It's up here in the title. Should also just go to Grafana's webpage, just show off all the tools I'm using. So yeah, this is the front end, Grafana. The database I'm using is InfluxDB, and it's made by these folks, Influx Data. They have a business model kind of like MySQL, where they have like a, like an enterprise product that's all clustery and such, but then it's all based on an open source core that anybody can use. So it seems decent. Like I'm pretty happy to support something like that, because it seems like the technology that they're putting out there into the kind of open source accessible world is quite valuable, and I'm pretty happy to have access to it. So not only do they have a database, but they also have these other components, which they call the tick stack. Where do we have a page about that? Yeah, so they have these few components that they like to tell people to use together. And so Telegraph is the data collector we're using also. It looks at like CPU and disk and hundreds of other things you can configure it for, and just collects data and shoves that into InfluxDB. Chronograph is actually a competitor to Grafana, which I have been using, but so far I haven't had as much luck with that for this very tightly spaced data like I get from TucoFlyer, just because it's been harder to navigate at that time scale. InfluxDB. So then that covers this dashboard. That's just Grafana, InfluxDB, and then the data comes directly from the Rust, the bot controller process that's written in Rust. And then on this side, these charts are actually written using a library called Smoothie Charts. And this is just a basic JavaScript library that just does the rendering into a canvas. You still have to give it all the data. You still have to do all the layout and everything else. So there's a bunch of other pieces that I use for that. I ended up writing all the WebSocket stuff myself because I needed to kind of tightly control how it handles latency and batches the data, because that was fairly application specific, or at least that's the way it seemed. It didn't seem like I could quite get away with just using something generic like MQTT to do this and have the level of performance I wanted. But maybe someone out there can prove me wrong, and I'd love to see that. So this is just using pretty basic WebSockets plus a custom batching layer on top of that, and then that's going out to Smoothie Charts, and then everything you see on top of that is just built with fairly straightforward React and a few React components, like a port of Bootstrap. So and if you want to see any more detail about how this is actually implemented, as always, you can get the source code. The whole thing is in the TucoFlyer organization on GitHub. But then if you want specifically like just the controller, which is the Rust code, and the web front end, that's in this repository. Yeah, and then Oetken is asking if I want to provide an open interface or API to control the whole system. The answer to that is sort of. I mean, the controls, I would imagine that I would want that to be in the context of someone participating in the live stream. So, like, I don't think it makes much sense to just kind of have this, like, detached sort of headless API to just, like, send commands to the robot, because that seems like you could really only use that maliciously. But, like, I like, the level it's at right now is, like, the API is, I mean, I don't have it, like, documented in terms of there are separate documents describing it, but you can read the source code to see how it works, and I've tried to make it pretty straightforward. But of course, you can only use that if you have like the right security credentials and you're connected to my LAN, so it's not really useful if you just want to control it from the outside. Whereas like if you're like participating in the live stream and you want to send commands to the robot, there might be various ways of doing that, but I think the main way I imagine that working is via chat. I think the two systems I'm most excited about right now are a bot that hangs out in Twitch chat and integration with letsrobot.tv. Maybe also something with like a Twitch client, or like a Twitch plugin rather, but that seems like a lot more work. And I don't know if they'd be likely to approve something like that. That's really just like for one broadcaster. I don't know. But yeah, there's some options maybe. Linkanu is also asking if they could see my most used programs, etc. on macOS and Windows. Why is that? maybe you weren't serious. Yeah, that's funny. I mean, I actually got interviewed a while ago for that blog, Uses This, I think it's called. Yeah. I don't know, they just like ask you what tools you like. And they interviewed me a while ago, and I probably even have different opinions now than I did then. So like if you're curious, like that's one place you can go. Yeah, see, this has all changed so much. I think I wrote this when I was living in a tiny studio apartment in San Francisco. I still have this monitor. I still like it. It actually got damaged a bit in my last move, but it's still really good. Yeah, I still use that power supply, but I have a nicer one now, thanks to Mark. Oh gosh, yes, I have definitely upgraded my O-scope since this, and my soldering iron. Thank you. And my 3D printer. Oh yeah, and what did I like back then? I was using macOS a lot then. I think I spend my time fairly split between macOS and Windows these days. And Linux, but more virtualized, and like Raspberry Pis and stuff like that. And yeah, I've been spending more time with like video production software than like 2D graphic design stuff lately. Oh geez, and I don't use Evernote anymore. I got tired of Evernote's garbage. Yeah, I don't know. So opinions change. I don't know why people care so much about them. Anyway, let's get back on topic. If I could type. Typing on this computer is hard enough even when I'm not streaming. Oh, Lincoln says it's just that it's awesome to discover tips and tricks and programs that you don't know. Well, fair enough. I mean, I don't know. I feel like you get a lot of that when you just watch me work when I stream that. Because I'll just have to like edit files of various kinds and like use tools. And I try to, I mean, a lot of what you see on the stream is like pretty much what I would use off stream too. So, I thought this might be fun to do. It's a sort of a web contest thing. It's hard to read, geez, how can we fix that? That doesn't help. Sorry folks, I'm going to change their text color so this is easier for us to read. Can I not highlight that element? Is that their text color? That didn't actually change it, did it? Oh, they have, oh geez, color 18 is apparently a style they gave this intentionally. Cool. Oh. Sorry, I just can't use DevTools without resizing a bunch of these panels so that it's actually openable. Where does that style even come from? There it is. Ooh. Oh, that's better. Cool. Can we make that bold even or something? Because it would be nice to. Oh, that's fine. I can just zoom it. I just couldn't quite deal with that color. I'm sure after video compression it would be even less readable. So, as it says, this is an opportunity to win 200 pounds. Since obviously if I stream this, it's going to be a bit of a team effort, and it seems awfully disingenuous for me to just like enter a contest and then like collect the prize money if like we win this thing. So, you know, if we do make something that's worth entering and we win, then we can figure out who to donate the money to, so that it goes to a good cause. Because mostly what I'm into here is the experience of building something, if we can actually make that happen. And I also highly encourage any of you who are interested to enter, because it seems like a lot of fun. I participated last year and I made something which didn't win, but I had a lot of fun making it. And I also had so much fun watching everyone else's entries last year. And so actually, yeah, can we look at some of the entries from last year? Because last year was much simpler. Last year the rules were fairly open-ended. You could really just flash a light bulb. I think the rate had to be between 0.5 and 2 hertz, but the duty cycle wasn't specified. You just had to be able to see the difference between on and off. So you can see now that there's 2017 and 2018 in YouTube already. So there were a lot of entries for 2017. It was really cool. And a few familiar folks and a lot of unfamiliar folks entered in this contest. You can see stuff from Applied Science and Mike's Electric stuff. And I found out about some cool new channels by seeing their flashing light prize entries. So it's also a pretty cool opportunity. Like if you're a small YouTuber and you want to get some interest and exposure, if you enter something, your entry gets on what's at this point actually a fairly short list, and you'll have people at least watching your video just to see what you did. And so it can be a cool opportunity to show off your stuff if you are into that kind of thing. So there were a lot of cool entries. Oh man, this was one of my favorites. I recommend watching this one. This one used a high voltage static electricity generator, so a Wimshurst machine, to generate these big sparks. So it's actually a pretty old school static electric generator. It's one of the first machines that could generate large amounts of static electricity with a controlled polarity, and then you could store it in a Leyden jar, which is an early capacitor. And this uses an automotive ignition coil transformer in reverse to convert it to convert this giant electrostatic spark into a voltage that's tame enough to run a light bulb without burning it out. So that's very cool. Yeah, Oetkin says there are really nice vids on YouTube about the flashing light. Yeah, a lot of really good stuff. Oh, this was a really nice build too. This one, it's like a pretty simple concept that mechanically rotates the light bulbs and flashes a different one each time, but it's just a really beautiful build. So I definitely recommend going through these. There are some really good entries. I don't want to steal anyone else's thunder, but I will play mine because I don't mind plagiarizing for myself. Let me just make sure this is muted. So yeah, this was my entry, the induction swing. And, you know, so people had all sorts of different ways of turning the light bulb on and off. In this case, this swing is actually powered by, it's a pendulum that's powered by compressed air. And then the light bulb actually glows using basically an open air transformer where the primary side is an induction cooker and a copper pipe. So that was fun. The thing in the back is just the GoPro we were watching it through before. Aw. Well, we'll figure out who to you know. Well, if we end up like with something that's worth entering, I was just looking at James's comment in the chat saying that that's $277, 225 euros. And then James is saying it would be they'd be fine with it going into the Patreon money fund for like paying rent and buying cat food and all that. And yeah, I mean, we could do that. I'm sure that some of you would be fine with that, but I also just feel like if, you know, we're entering a contest together, then that's a good opportunity to try to have the money like go to an especially good cause. So we could think of something especially appropriate here. So yeah, anyway, a lot of people ended up with these YouTube videos that went on and on because in the requirements for the contest, your thing has to keep going for 5 minutes without breaking. So a lot of people showed their thing going for 5 minutes. So this year the rules are somewhat different. Your thing only has to go for 1 minute. I don't think it's significantly different, but there are some actually significantly different requirements here. So there are actually 2 prizes, first of all. There's one for, quote, ingenious, unusual, clever, and elegant uses of science and technology, and another for crazy, absurd, and humorous contraptions. So, and then there's, of course, overlap. So I could see a lot of different potential here, like ingenious uses of technology. I think I'm definitely itching to use a couple of kind of niche physical phenomena here. And I want to take a look at Ben Krasnow's entry because I think I will actually play his because I think he might have gotten that idea from me, so I can at least play his video while I'm explaining this. Because I think I might end up doing something slightly along the same lines, but I'll try to make it different enough that I'm not stealing his thunder. And yeah, so there's some interesting things we could do technology-wise. You could also just like do something pretty straightforward and just put a neon bulb on it, but then just make it really funny. And I think people have done some really interesting humorous entries for the previous year's Flashing Light Prize, so I definitely recommend taking that approach too. Like, who was it? VJ? I'm forgetting his full name, but his first name was VJ, I think is how you say it, V-I-J-E. But he had like a half a dozen different entries that were all these like minute-long skits where he built a project and then like videoed it in this really creative way. So that was really cool. I think, you know, that kind of thing would totally fit into judging criteria B here for this year's Flashing Light Prize. Yeah, as Oetkin says, there's mechanical stuff, electronics, design. Yeah, right? I mean, that's one thing I like about this contest is it's extremely frivolous, but you can bring together a lot of disciplines and do something kind of interesting that way. So yeah, and the rules are actually a lot more specific this year. So yeah, I'll just read through the criteria a little bit. You can use anything that's mostly neon gas in it, which can be made to flash visibly. So it might be a small mains indicator bulb, a neon sign, a Nixie tube, some exotic lab equipment. It's up to you. The means by which you cause the neon to flash on and off are also up to you and are what this contest is about. And also that mostly neon gas seems interesting because, of course, you know, you're not going to find stuff that's purely neon. Everything has got some traces in it. But I wonder like what you could do with that sort of opening for stuff that has other gas mixtures. Now this is where it gets much more specific. The flash rate must be 1 Hz with a 50% duty cycle. This is what I've agonized over for. This is like the main reason I haven't done an entry so far, is I'm like, how do I do that? Since I think this is just like it's a big opening for creativity here because the accuracy is not specified, I think. So it makes me wonder, like, is it going to be judged prioritizing accuracy? Is it going to be judged where, like, that kind of factors into, like, well, I mean, I guess it's just a big open question. Like, you know, could it be, I guess it just encourages me to play with that, is what I'm getting to. It makes me think, like, well, how could I play with the concept of this accuracy, but also the inherent inaccuracy of something like a neon bulb. And I don't want to jump ahead too much, but this has me thinking about doing something that involves combining a GPS referenced clock with some kind of really inaccurate analog system to cause the rate to settle. So that might be interesting. And yeah, the system has to go for a minute at least without exploding. The flashing must be done by the neon gas glowing, turning on and off. So you can't just use shutters or lenses or whatever to actually kind of turn the light on and off. You have to actually make it glow and then not glow. But, you know, it doesn't say it has to be like electrical in nature. It just has to be the neon gas glowing. So that's interesting too, right? So how to enter, you build the thing, make a video, put it on YouTube, and then tweet at them or email them. And the deadline is March 15th. So today is February 12th, so we have about a month here. And the other thing is you can enter as much as you want. So if we come up with a bunch of ideas, we could enter a bunch of things. If all of you each want to enter 30 things, you could do that. If you all want to, like, form teams and enter stuff, like, you could do that too. It's just a weird thing. You could all do it or not. Like, it's completely up to you. Isn't that cool? And they like things that look nice, which is cool. And they might like exotic neon bulbs, which is cool. And also warning, don't hurt yourself, because this might need high voltage and sharp things and whatever, and nobody is responsible if you hurt yourself except you, so don't, etc. Kevin on YouTube chat says, I call BS. About what? I don't understand what the context is, but thanks. Always need someone to call it like they see it, I guess. Or that sounds like something I would say before being on the internet for as long as I have. Anyway. So yeah, let's take a look at some of the entries so far. I don't know if there are a lot, and I don't want to like play other people's videos, but I do want to at least look at the entry that that Ben put out, since it uses a technique that I think might be familiar. So actually, first of all, let's take a look at a video that I put out a little while ago. Does that find it? Yeah, both of these first two actually. So this is actually just the effect I'm talking about. Let's look at this in real life too, but this is something I documented a little while ago. when did I actually publish this? I published this video in like August 2016, but I think the first time I actually published it was in this video blog, which was March. So anyway, it was kind of a weird effect. Like, this was like kind of an arty blog post where I was making this thing, which I have on my desk now. We're going to take another quick look at it. But I found this little aside where this neon bulb, which in this case we're powering from a CCFL backlight inverter with high frequency AC, which that itself has an interesting effect because it's different than powering the bulb with either low frequency AC or with DC, because if you power it with DC, you get a glow only on one plate. I think the cathode, if I remember right. Don't quote me on that, that might be wrong. But if you power it with AC, then you'll get a glow that kind of, flickers and dances back and forth a little bit, but is fairly even on both plates at like normal line frequencies. If you step up the frequency, then you can get a state where the ionization in the air can't actually fully extinguish during the zero crossings in the AC waveform. And I think, if I remember right, something I was reading for neon bulbs, it was on the order of like milliseconds or maybe very low tens of milliseconds. And so if you have an AC waveform that's much higher frequency than that, like these CCFL inverters, then you can just get the the neon to stay ionized. So that might have had some bearing on this effect. But yeah, this was pretty cool. Basically, this is glowing, and there's this uneven glow because parts of this are a little bit below the threshold where they can glow, and parts of it are a little bit above, and so it's glowing in areas and not others. I didn't actually know that much about these bulbs when I first started experimenting with them, but I did some research since then, and there's actually, there's a patent about this. Can I Google for this trivially? I think that's it. Oh no, that's for a controller. Yeah, Unstable Moving Flickering Glow by Philip J. Kyatt in 1962. Doesn't that look familiar? Different shape, but it's got the same electrode inside. And so this is a wild process. Like, it's not entirely clear to me how much is understood about the chemistry here. Because it seems like when they developed this, it was just kind of like a trial and error thing. But check this out. They're dipping the electrode in barium azide, which is kind of a nasty chemical. Like, barium itself is... so what they're doing is they're leaving a porous barium coating on the electrode, I think. And I don't know what specifically that does chemically, but the effect that they're documenting here is that it, what do they say? It evens out the work function of the surface. And I don't even know enough about the actual electrochemistry of what's going on to really understand the details there. But I think what it's doing is that it keeps the glow from stabilizing too much in one area by kind of creating a feedback loop that pushes the glow away from the areas where the glow is happening, if that makes sense. So I'd love to know a more thorough explanation of how this method actually works, or if that has even really been determined. Because from the research I was doing so far, this patent was actually one of the better resources I could find, and it documents the effect, but it doesn't seem to explain why it happens. So yeah, it's really interesting. So I as far as I know, all of these bulbs still have barium-coated electrodes. So definitely don't handle them too much. If you break them open, I would recommend. Barium is pretty carcinogenic. And barium azide is explosive, so I definitely would not recommend trying to make something like this at home. But yeah, this patent has some interesting info, and you can buy these bulbs cheaply, and they're interesting devices. So that might be something to incorporate into this project. So yeah, I don't know exactly what's going on here, but I think that sort of unstable work function or whatever it is that's actually causing the glow to not settle down in one space, I think that we're also influencing that with a photoelectric effect. Because I experimented with this and I could only get this to happen with like near ultraviolet blue laser. So like here I'm trying it with red and green and I couldn't get it to work. It only worked with this sort of blue near infrared laser. And it's a pretty intense laser. Like it's one of these like 5 milliwatt lasers, but I would only run this with safety glasses really. And yeah, you can just like grab onto that spot of discharge and move it around, which is interesting. Paul's saying thermionic effect. Oh, that's interesting. I wonder. So that, I guess I don't know whether you're talking about just the cathode glow. So whether we're talking about just like glow discharges in general or that particular effect, but I think we're pretty sure that that's photoelectric because it only happens with the shorter wavelengths. If it was a thermal effect, we'd be able to get it to happen with just really intense red lasers, which I couldn't actually see that happening. Looking over at YouTube chat, I still don't know what Kevin is called BS on. The world may never know. So sad. Anyway, let's take a look at that other inspiration that Ben might have beat me to. It's 2018. Yeah, so we've got a couple of entries so far. YouTube is not amazingly great at giving me just the 2018 entries. Can I quote this and get better results? I really hate how non-deterministic the search engine on YouTube seems to be. This is why to email them if you enter, because I don't know if they can even search all the entries effectively. So anyway, there are a couple of entries for 2018 so far, which I encourage folks to take a look at. The one I wanted to look at here was Ben from Applied Science, and this is really interesting. So he's using, I think, that same kind of effect that we're assuming is photoelectric to light the bulb, but he's combining it with some other really interesting elements. He's coated the bulb halfway with sunscreen and then rotating it. And instead of using a laser, he's just using a really intense ultraviolet lamp here. And then he's powering the whole thing off of 60 hertz AC, but at just a little bit below the voltage that would normally cause it to light. So I think what might be going on here, and I don't think he quite explained the effect in detail, but I think that might be like photoelectrically boosting the voltage at the surface just barely enough to get the glow discharge to light. But it's strange. I don't know that we actually understand the mechanism perfectly. Danwei is saying something temperature related, definitely something temperature related rather than light. No, I think we ruled that out pretty conclusively by testing the wavelengths. If it was temperature related, we would be able to get it to happen with an intense longer wavelength laser, which we couldn't get. So that's that. That's the contest itself. I think I think at this point I want to switch gears a little bit into figuring out what we can build on this stream that might be fun. So I've got some hardware here on my desk. I need a brief restroom break though, so I think I will do that and leave you with the cat cam momentarily, and then we'll return in a sec. Danny is asking, have I tried UV? So it's, yeah, I think the one Ben is using is like a black light. So it's it's like mostly UV, but it's still just barely visible to us as a deep blue. I don't know what wavelength his light is. The laser I've been using is 405 nanometer, so it's like not quite UV, but it's close. I don't have a deeper UV laser here, but I have pretty intense like red and green lasers, and the green laser I have is more intense than this, and I couldn't get any results out of the green laser. Oh yeah, Michael says that they've been meaning to get going on flashing light prize and might want to drive it with RF. Yeah, right. I've been thinking about that. I don't have a lot of the traditional like high voltage stuff around here. Like, we should maybe go into some of the like old school references, because this thing like doing. Oh, there's actually some more inspiration I wanted to show you, but I do actually have to pee, so I need to join you folks after a brief restroom break. Yeah, definitely got to bring a few more inspirational references into this. This has come up in the chat a little bit, actually. We've talked about logic made from neon. It's just so cool. And there's a clock I think we need to take a look at. Oh yeah, actually, here I am catching up on the chat and realizing that the chat has also just started talking about neon logic also. Yes, so I guess we're on the same page. Yeah, Michael says kind of like a little Tesla coil or plasma globe supply, since considerable impedance transformation will have to occur from a transistor amplifier to something neon sitting on the end of a wire. Yeah, I think, so that was like on the topic of exciting the tube with RF. Yeah, definitely. I mean, the CFL inverters that I've been using so far are kind of on that spectrum, and I also have a tiny Tesla coil here that I think we can try using for that. It's just the littlest Tesla coil. So yeah, we should try that out. Oh yeah, and Paul says in chat that they think Hackaday had an article a while back on neon logic with bulbs being used as vacuum tubes, and vacuum fluorescent displays have been used for logic before. Yeah, I think Hackaday did have an article like that. We should take a look, or I'll get that on the screen in just a sec. And yeah, vacuum fluorescent displays have definitely been used for logic. I mean, vacuum fluorescent displays have been used as amplifiers, and you can certainly make logic out of amplifiers. I mean, in vacuum tubes that are constructed in basically the same way as a neon bulb are actually really common, and they're usually used as voltage regulators. I mean, if you manufacture a neon bulb such that it has a very specific voltage drop when it's ionized, that's basically how voltage regulators worked for a long time. Like, that's the vacuum tube equivalent of your 7805 regulator these days. It's just, you know, it was like regulating it to 70 volts or something instead of 5 volts. James suggests switching the RF on and off with a big knife switch driven by a servo. Yeah. Maybe something pneumatic to keep the high voltage and low voltage as far apart as possible. I do like the idea of driving like modulated Tesla coils using like optic fiber, like Toslink cables. Oh, nice. Oh, cool. Michael says that they're planning on deriving both the 1 Hz frequency and the RF by division and multiplication from a watch crystal. That's great. Yeah, okay. I guess this did make it to Hackaday. Was this where I first saw it? I can't remember. Yeah, so this thing is quite an inspiration. If you start reading about this will lead you down an interesting rabbit hole. Can we watch it working first? Yeah. So this is made with neon ring counters, which are quite a little oddity into themselves, which might be interesting to read about. How deep do we want to get into that right now? Probably fairly deep, right? This all exploits the difference between the voltage that it takes to get the tube to initially strike and the voltage that it'll then kind of settle to as it starts acting like kind of a Zener diode, effectively, like a big voltage regulator. And so a neon ring counter is a way of connecting multiple neon bulbs together so that every time you send a pulse into the system, you can get a signal to kind of propagate from one bulb to the next. Yeah, so I've been looking into these because they definitely seem like a good thing to use for a flashing light prize entry. Yeah, I think this is the page to read. Oh, yeah. Yeah, so there were a couple of these accounts that I was reading. This might have been the most detailed. Yes, and this is the same clock that Hackaday picked up, I think. Yeah, so one thing that's kind of unfortunate about this, which this page makes clear, is that I'll just read this paragraph. So unfortunately, if one substitutes the neon bulbs that are available in electronics shops nowadays, the circuit doesn't work. Dance, who is the J.B. Dance, the publisher or the author of Electronic Counting Circuits, which was the inspiration for this. Yeah, Electronic Counting Circuits by J.B. Dance, published in 1967. So Dance used lamps that were specifically manufactured for this type of application, with a large difference between their striking and maintaining voltages. Nowadays, such lamps are presumably no longer manufactured. The neon bulbs that are still available in shops are meant as indicator lamps and have a much smaller difference between their striking and maintaining voltages. This required changing the circuit's resistor values and makes its operation more critical. Furthermore, the lamps need to be selected for the matching characteristics. This is one of the ring counters. It's great. So I admit, when I was reading this, I have this terrible impulse anytime there is a fiddly analog circuit that doesn't want to behave, is I want to wrap a digital control loop around it to get it in the sweet spot. Which is, like, I guess a pretty common impulse for anybody who designs electronics, like, within the last few decades, maybe, but it's, like, very different than going this route and having something that's entirely made of neon bulbs. Sorry, I'm a little behind on the chat. Let me see if I can read the scroll back a bit. Oh yeah, Vince has some of those vacuum regulators. They're for 85 volts. Interesting. Yeah, pleasing glow. I think a lot of them glow kind of blue, don't they? Because they don't necessarily have neon. They could have any gas that'll sustain a glow discharge. Old school spark gap radio transmitters. Oh, and then Whisperfist has a question about power grid reliability. Yeah, I use UPSs a lot. Some of that is just because, like, I like to be able to reconfigure stuff without powering it down a lot, so I can like move around entire like desks full of equipment if the whole thing is on a UPS. So that's a lot of the reason I have stuff on UPSs, but the power here isn't amazingly reliable. Like, we've had a couple of small outages just in the last year or so. So, like, if the stakes are, you know, an outage just like crashes your storage server, then it's nice to have a little bit of assurance that it doesn't happen all the time. And so actually I can run most of this shop on battery power. We had a power outage in the middle of the night, actually kind of recently, like a few weeks ago, I think. And it turned out to be like a 4-hour outage. So I might have even been able to run a lot of the shop through the entire thing, but it happened in the middle of the night, and so it woke me up with beeps, and I had to go around turning everything off. That was funny. But yeah, I've got a few separate UPSs here. Oh, cool. Oh, great. I haven't seen this one yet. This is a ring counter for this year's Flashing Light Prize. Yeah, so I assume, like, the way you would do this, I assume, would be to run the timing off of your 50 hertz or 60 hertz mains, and then divide that a bunch to give you a flashing light. This looks like a pretty classic implementation of that. Yeah, only ring counters. That's really good. Yeah, well, definitely watch this video. I'm not gonna play the whole thing, but yeah, that's great. Alexi says there's 2 ways only: to change voltage or not to change voltage. Ben's only on the second side so far. You might be right about that. I hate reducing it so much, but I mean, you might be right about that. I do like the idea of keeping the tube. Well, I don't know. So I keep going back and forth between, like, wanting to have an open-ended discussion about all the things you could do, and then just, like, a discussion more specifically about the ideas that have been bouncing around in my head for this. Related to stuff that I've had on my mind, I would love to have a neon bulb which is driven by an off-the-shelf, like, low voltage to high voltage step up of some sort, like a CCFL inverter or one of these, like, spark generator modules from eBay or whatever. And then to, on the primary side of that circuit, use the neon bulb as a light sensor to detect a laser coming in from a GPS unit, like, elsewhere. That seems neat to me. Like, I like the idea of having, like, a GPS stuck to the window with a laser pointer that sends out a pulse that then gets received by a neon bulb on the other side of the room, which then flashes. And I don't know whether you'd have to have one neon bulb acting as the receiver and another acting as the transmitter, or if you could, use one for both. I think that would depend on how the measurement even worked, but I'm imagining something about the voltage or current, or possibly EMI on the primary side of that could be measured by a suitable system. So yeah, that goes back to my dirty habit of wanting to take these weird unstable analog systems and wrap a digital control loop around them to kind of settle them down. I did something a while ago like that to make an RFID reader. Yeah. So this is an RFID receiver. That's a propeller microcontroller, and this is just a breakout board, basically. I'm not using any of the other peripherals on here except the television output. So yeah, all this is some resistors and capacitors and a diode. Did I have a diode? Yeah, that's a diode. So you might recognize all the fundamental components of a radio here, except no transistors, just the diode. And it was based on creating a closed-loop feedback system between the software and the hardware that would then detect the amplitude-modulated bits. So it'd be interesting to do something kind of like this, but through the CFL instead of through the air gap here. So that could be interesting. James suggests the dark room with mirrors and a fog generator if we go with the laser approach. Sure, I can turn off the lights and turn on the fog machine. And this is interesting too, the actual Nixie tubes, which of course this clock used Nixie tubes as output, they're driven by these sort of optocouplers, which are pretty interesting. But yeah, this is an interesting kind of epilogue here. These circuits tend to be really unstable, so we were talking before about how you have to, pick just the right neon bulbs, or actually, did we even get to that point? I mean, we started down that path of how, that paragraph up at top about how the, today's neon bulbs are much less critical about their sustaining voltage. So yeah, they actually, everyone who builds these has to select neon bulbs that are very well matched. And then of course they drift over time. So was it this page that actually had some plots about that? This is really good. I definitely recommend reading this in detail if you're interested in this at all. This is dosforever.com/ring/ring.html. Yeah, this was really the first page where I read this and I actually understood how these counters worked for the most part. It's showing these stages where it's transferring the pulse. And this capacitor and the set of diodes, that's what causes the difference in striking voltage from tube to tube, so that the glow jumps to the correct tube when the next pulse comes in. Oh yeah, yep. This is the page that talks about aging the tubes also. Breaking them in, yes, so anybody doing this is going to have to deal with all of this too if you're really sensitive about the voltages. So the idea is that the tubes change a lot over their lifetime, but especially when they're brand new. And so you let them break in by just running them a bunch, and then you measure their characteristics and try to bin them together so that you have similar tubes in the same counter. Wow, a switching tube. Oh wow, these also use barium. Does this explain why they use barium? Oh, photoelectric priming. Oh, see this. People must have documented this. I just don't know where to look. It's probably in that counter book from the '60s. I should just try to find a copy of that. Diffusion processes in the barium layer contributing to the aging. Wow. So this is a special kind of neon tube designed for switching applications with 3 leads and a separate electrode that doesn't have the barium coating. Because apparently that was... this is really fascinating. Switching diodes. Sputter cleaning of the cathodes. Yeah. Oh man, I just had to laugh at this rumor that you can build a counter out of a single Nixie tube because people just treat the electrodes as individual neon tubes. But I don't think they could possibly work because all the glow discharges would influence each other. Oh, and apparently also neon or Nixie tubes have a very low difference between striking and maintaining voltage. Oh yeah, and once any of the digits strike, the other ones don't really need the same, or don't really exhibit the same hysteresis. Yep. Oh, Glasslinger. Yeah, that's a great YouTube channel. They make some really, really amazing like glass. You can watch them make like a little triode on YouTube. It's really cool. Wow. So much work went into these. Huh. Mako MK says they think they built an RFID reader that's a distant descendant of that with added complexity. That would surprise me because I'm not aware of any other designs based on that one. I'd be kind of curious to find out about that. And Mako MK also says, wait, was there a note in there about radioactive priming to get a more consistent strike voltage? Yes. That is common in, well, maybe, I don't know about common, but at least like relatively frequent for voltage regulator tubes at least. Or was that on this page? Oh, that's, they're explaining the barium cathodes here. I'll just read this paragraph. The vast majority of all neon tubes use a barium-coated cathode. Barium-coated cathodes have two advantages. First of all, metal cathodes have to be cleaned in situ by sputtering. During the sputtering of the cathode, also a non-transparent metal film will be deposited on the tube envelope, so that the glow will only be visible at the ends of the tube where less material is deposited. Oh, interesting. So barium keeps you from sputtering metal off of the electrodes and coating the inside of your tube while you're manufacturing. The second advantage is that due to the low work function of the barium coating, normal visible light can be used to photoelectrically primer the tube. This probably needs a bit of explaining. For a reliable striking of a neon tube, a certain number of ions need to be present. A few ions per minute are formed in the tube by cosmic rays and by radiation from stray radioactive atoms which are present in all materials. But more ions are needed if the discharge must always be ignited or initiated rapidly. Artificial methods for increasing the number of ions in cold cathode tubes are known as priming. Apart from photoelectrical priming, also sometimes an additional priming electrode is used, or a little radioactive tritium gas is added to the gas mixture to enable rapid and reliable striking of barium-coated tubes even in the dark. That's pretty great. So yeah, and then they talk about switching tubes, and so you would have found like a high-speed switching tube in the past, maybe, that would use radioactive priming. Yeah, that's Glasslinger. Oh, this is so interesting, and there's so many places we could take this. I would love to even just look at a like we've seen various oscilloscope traces showing the striking waveform. Like this one. I would love to be able to recreate this, but then try like sending various light sources in there and watch the waveform change. The easy way to generate something like this is with a high voltage square wave generator, like an off-the-shelf piece of lab equipment. I don't actually have one of those, but I'm sure we could improvise something. I'm really tempted to see how far I can get with just doing this all in the low voltage domain. Just like stick some kind of low voltage to high voltage power supply in the mix, and then just do all my probing and power supplying on the low voltage side, so I don't have to use anything especially specialized right now. That might be fun to do, and then we could just hook this up to a ramp generator and put ramps into it. Alright, I actually need another brief restroom break, so I'm going to leave you with the cat for a minute. Vince is asking how high low voltage is for me. I mean, it depends on what kind of tools I'm planning on doing, but software I'm using, but like in this case, it'd be nice to have something that's within the range of like my scope probes and signal generator. Ode to Odd Video on YouTube chat asks, am I working on a neon music VCO? Well, that's a new one. Is that a thing people do? No, I'm not working on that, but that sounds like an interesting idea. Anyway, let's just go to the overhead camera here and look at some of the objects on my desk and try to make something out of them. So for anybody who is wondering what I'm actually working on, we're trying to work towards something that might be a flashing light prize entry. And so I already went through some explanation about what that is, but if you're just joining us, if you go to flashinglightprize.com, you can see what it is. It's basically just try to find a creative way to flash a neon bulb. If we end up making something and entering it and winning, then we'll figure out who to donate the spoils of the victory to. That sweet 200 pounds. So, yeah. Oh, Michael says there's a whole thread on electro music or muffle wiggler about that sort of thing, neon VCOs. Oh, interesting. Well, let's take a look at that since you're asking. I didn't know you could get these to oscillated audio frequencies. For many years, designers of electronic organs have tried to design instruments with neon lamp relaxation oscillators as tone sources. Neon lamps are economical, and they yield a sawtooth waveform ideal for a formant tone coloring system, the type of which makes possible many of the most realistic limitations of pipe organ and orchestral sounds. Yeah, I'm not going to read this whole thing. But that's cool. It definitely is smaller than a pipe organ. So, okay, this figure A here is a standard neon relaxation oscillator. So, I understand how these work well enough to explain them at least. So what's going on here is that you have a power supply, which is B+ in this case, and you're applying that power to this neon bulb and capacitor in parallel. So you can, first of all, just ignore the neon bulb and imagine that you're just charging the capacitor through a resistor. So it's going to charge over time, give you the standard like RC time constant kind of curve. But at some point, the neon tube is going to start to ionize the gas and conduct. That'll happen at that striking voltage. So then at that point, it kind of dips back down, and then it goes below the striking voltage. What causes it to not sustain? So if there was enough energy in this capacitor, this would just keep glowing indefinitely. But the way to get this to oscillate is that there is to make this resistor high enough that there actually isn't enough current to sustain that glow. So you end up dumping the energy in this capacitor into the neon bulb. It flashes really briefly, but it can't sustain the glow through this resistor. So then the process repeats and you get that cycle. So I guess the thing I find surprising is I just didn't know you could do that at audio frequencies, because I thought neon tubes took more time to turn on than that, like milliseconds. I mean, I guess maybe this means it's like 1 or 2 milliseconds instead of like 6 or 8 milliseconds, and maybe that's enough. Okay, so they're going, this is pretty low base, like they're going down to 32 cycles per second. Okay, 3951 hertz down to 65 hertz. That's pretty good. This is pretty neat. I had no idea you could do this at audio frequencies. I'm just also kind of skimming this for like, well, why, how does it go so fast? Oh, Piotr has a video. I guess we can check this out. Growly. Yeah, okay. I get why people like these. Oh. Yep. So, that's cool. Yeah, I can see why you'd want to build one of those. That seems like a lot of fun. And I also suspect, meaning to mention this, but yeah, so neon oscillator, or neon relaxation oscillators are definitely a thing, and they're so simple that you can make them by accident sometimes, because all you need is a neon bulb and a resistor and a capacitor. I think that the 50% duty cycle rule was specifically just so that they wouldn't see so many neon relaxation oscillators. Since you do at least need some kind of duty cycle correction stage right after that. At least for this flashing light prize, not to make audio. For audio, you can just like do whatever you want with that waveform, right? Oh, interesting. Ode to Odd in YouTube chat also adds that flashing neon bulbs were also used in very early analog drum machines like the Seeburg rhythm prints. There's also a video about that on YouTube if you're interested. Yeah, well, I wonder if just internally, like, that was a good indicator, or if some of those might have actually used neon oscillators. I don't know how practical that would be, because it just seems like they're so sensitive to external influence. So, like, all of these tiny currents and little differences in voltages and temperatures and things are going to get it out of tune after that point. James is like, all you need is a flip-flop after that, right? Well, yeah, just only. Right? I mean, all you need is a flip-flop. You just have to build one of those out of neon. I mean, that's what the neon ring counters do, right? Like, you could build a neon ring counter which is fed by a pulse generated by a relaxation oscillator. Like, that's like one way to do this. That would just be extremely fiddly. Like, you'd have to tune it just right, and that's not quite the adventure that I'm interested in having. Like, I would rather build something that has its own closed loop system inside than something that I need to tune. Oh yeah, and SPO was mentioning, yeah, I bet some of the older, like, neon tubes designed for this would have actually made pretty good oscillators. Like, you know, the ones that included tritium or whatever. Paul's like, all you need is a couple trillion electrons to behave, right? Yeah, this is neat. Well, what do we got on the desk? So this thing's still running. Let's take a look at this. This is the thing that I built a while ago, which has still been... This has been running pretty much continuously since I built it, and you can see some sputtering on the inside of the tube, actually. So wait, when was that? 2016? No, not 2016. 2014? No, okay, only last year. This seems like it was so long ago, but okay, so I only built this thing like... Well, I made the video about it last year. When did I build it? Oh yeah, no, I built this thing way before I made the video about it. Oh wait, I probably put a date on the back. Oh yeah, 2014. And I made the video about it in 2016. Cool, so that's 3 years worth of sputtering. Yeah. Oh, Paul says I can get some americium from smoke detectors. Yeah, I bet I could. For radioactive priming. Flame effect complete with soot, right? Yeah, it is a little sooty now. Anyway, let me give a brief demo of this laser effect. See that? Just making sure I'm not hitting anybody with this. There. I don't know how much the color change is coming through on the camera right now because the colors are pretty weird in these glasses, but that's definitely grabbing it. See that? So I think if I had an O-scope on there right now, I would be seeing some interesting waveforms. So let's maybe do something like that. Put this aside and try making something out of these parts. Oh, Paul's been lurking since Coaster Melt. Oh, Pete says it's 2018 now. Yeah, but it's like the very beginning of 2018. I'm not going to count that as an entire year. Yeah, I was thinking about Coaster Melt recently, actually. I would still really love to get that to the point where I can get some like interesting data off of the surface of the disk. I hear that that specific drive has gotten harder to find, but I still have a handful of them here, so I could continue that. I could also make one of the first steps trying to update it for a newer drive that uses the same architecture. Oh, my safety glasses are so dusty. Okay, so we've got a few options. I've got some of these same flickery bulbs. This looks like basically the same size I used in that thing from 2014. These are just bigger, 130 volts. They're just kind of chunkier. Neon, electrodes, a lot more room in there, right? This might be fun. And I've actually got a bunch of those. Like, I ordered a bunch of these cheap on eBay a while ago. So we could do some experiments with these, make something that needs several of them if we needed. And then as for power supplies, so I've got that tiny Tesla coil I mentioned, which could be fun. With this, the amount of coupling that we're going to get of the the current back into the Tesla coil is going to be very low. So I don't think this is the best option for using it as a sensor, but it could be fun as the output stage. This is also a very simple Tesla coil. I think that's just like a 1-transistor oscillator. This is so weird too. It's like all handmade. I got this on eBay, and someone's just like making this really simple handmade circuit and selling them on eBay. It's really interesting. Actually, this is the box, Sunny Tech. And there's another neon bulb. I also have a bunch of these kind of NE2 style bulbs. These like basic neon indicators, which might be good. I think that's the same kind. I think these glow green, if I remember right. They're neon, but with some other phosphor on top. Or maybe argon. But yeah, they're phosphor-coated bulbs with glow discharge, which is pretty interesting. And yeah, so then for power supplies, I've also got these things, which are like scary high voltage power supplies that you can get on eBay. These are the ones that are often sold as like 1,000,000 volt step up power supplies, and they're not 1,000,000 volts, but they're like still pretty high voltage. They're basically like ignition coil style modules with an oscillator. And so we could try that. I think this might be just aesthetically a bit nicer and possibly a little easier to work with. These are just more cold cathode backlight inverter modules. So very similar to the one that I've already built. This is VN. This one has a dimmer input. That's interesting. Yeah, this one has a dim and on-off input. I wonder if we're going to need to supply signals or whether these pull-up resistors are set to just have it turn on by default. This has an IC on it. BIT 3105. Huh. These are somewhat more complicated modules than I was expecting. Let's see if there's any data for this on the All Electronics website. I was hoping to use a very simple like analog CFL that I could easily run at very low voltages. If this has any smarts in it, then I don't think I can rely on that. INV 1011. Jessica says you only need a couple hundred volts for a glow discharge. Not even that. Like around 100 volts is probably fine in a lot of cases. It really depends on the bulb, though. The ones that I'll get here are certainly going to strike off of the like 120 volt line voltage. By the way, public service announcement, don't ever connect a neon bulb directly across mains. That's not how they work. They're like LEDs. You need a current limiting resistor. Jason is asking if I have a filter to filter out the color of the laser itself on that demo. I mean, other than the ones I was wearing on my eyes, I don't know. I'd have to go rummage. I didn't have one handy. This is the inverter I got. Only runs on 5 volts, refuses to turn on at other voltages, has a bunch of protection circuitry, only drives a load on a certain range. This seems like not the one for this experiment. Okay, well, I think I have other CFL drivers, but we could also try one of these big ol' scary modules and just see what it can do. I don't really want to run this thing open circuit because I don't want like giant arcs all over my desk covered with test equipment right now. So I'm actually maybe going to solder this to the neon bulb and then try running it at low voltages. Maybe just tacking it on. Oh yeah, also, I think the easiest way I have of testing neon bulbs right now is with my insulation tester, which is like a high voltage multimeter, or a high voltage ohm meter specifically. So this is designed to apply a high voltage across something that you want to stay insulated, like between the primary and secondary of a transformer, and it will tell you if there's any kind of breakdown by measuring the voltage across it. But you can also just use it as a high voltage, low current voltage source. It has 250 volt, 500 volt, and 1000 volt ranges. And the battery's low. Let's replace the battery. Oh yeah, Megger. Yeah, that's another name for a tool like this. It was the original brand, Megger, because it was a mega ohm meter. And the original ones were hand crank powered. They had a little high voltage generator in there that you'd crank by hand. It's pretty cool. But yeah, you can definitely just use these as a high voltage power source. Not quite their recommended use, but I guess I need to take those screws off too. If I remember right, this thing is just full of AA's. Oh no, it's full of leaky AA's. Well, shall we fix that now, or put that off? I think we should do something about this. Let's get my battery waste container and some vinegar. I even have that many alkaline AA's? I don't know if I can use nickel metal hydride in there. Anyway, I'm just pouring a little bit of white vinegar to use for the cleanup. Took is still sleeping in the same spot. Really giving the camera tracking a workout. Q-tip time, right. There's some discussion about meggers in the chat, and yes, this one does tell you the voltage where it starts conducting. It gives you ohms and volts. You give it the maximum voltage, and then it tells you the actual voltage, and I think the way it's implemented is it's basically a current limited and voltage limited power supply, and so the current limit is fixed. I forget what it is, but it's pretty small, and then the voltage limit is adjustable or selectable. This would be easier if I just put on gloves and grabbed it. I'm curious. MK said they had a really terrible idea in YouTube chat. What's your terrible idea? Or are you just going to come out with a flashing light prez video about it? Gross. Man, who invented batteries anyway? I didn't even leave a trash can over here. Oh man, why do I have to take another restroom break? I might be drinking too much tea. Let me see if I can at least get through this cleaning. Fine. I should use the restroom and grab a trash can for the Q-tip waste. I'll leave you with Took again for a sec. I think I've got a spare bucket in here in the 3D printing closet. Yeah. Sometimes the shop just needs a good bucket. Oh, Whisperfist is wondering how easy it is to recycle used cells in the US. It varies. I think there are some retail stores that take them, and some municipalities have drop-off stations. I forget what the closest option is around here. Actually, I haven't taken my cache of batteries out in a while. Good and fizzly. This spring is the most corroded part. Right now I'm just trying to get vinegar on all of the battery leakage, which is very basic, and this being an acid will neutralize it, which is what you're seeing. I think I should switch Q-tips. Sop some of this up and then do another pass at it. I was watching this video this morning on hard disk data recovery, which is kind of interesting. And it was like watching someone with their process for, have a little clean room, take apart the disk, replace the heads. Because I'd seen some earlier, probably pretty bad advice on resuscitating certain types of hard disks by replacing the controller, but I don't know how commonly the controller is actually the failure. And then this guy was confirming that, hard disks made anytime in the last couple of years, or a bunch of years at least, have some kind of calibration data on the controller that has to match what's on the disk or they won't work. So that was interesting. And then he replaces the heads on this disk a bunch of times before he manages to actually get a good image off of it. And then all the while he's like showing hex dumps from the customer's data on the screen, like as he's doing this. And then he finally has all the files recovered, and he's got a directory tree like showing, like the name of the person and their vacations and stuff, and being like, all right, we're done. And, but we won't show any customer data, It's like, dude, you just have been. That piece, I might just use the gloves and the Kim wipe to get some more of this. Fire in neon? Where's the fire? I don't see the fire. Are you folks having bad wishful thoughts out there? These are just AA batteries. See, if I were Big Clive, I'd need the Pi tin on my desk. I don't like taking apart lipos. Oh, the stick your drive in a freezer for a while to unstick it tip. Yeah, that's funny. I wonder how much that works. Oh, a flame sensor. Oh, I'll have to take a look at that video, or that picture. Interesting, I missed that. What? So we have a 1-to-1 isolation transformer. Oh, that's being used as an indicator. Okay. So they're using the conductivity of the fire and the tungsten so that the surface doesn't oxidize. You know, I actually do have some tungsten here. Because I used to take TIG welding classes, and I still have a couple of the electrodes I was using. Oh, neat. Ben has had enough luck to at least get a data image off of a drive via the freezer trick. That's pretty cool. Vince says dish it. What am I dishing? Am I dishing the... Is that battery goop on that screw, or is it plastic chowder? I think that's plastic chowder. Alright, let's do another couple of swabs with vinegar on this before I try to clean it out with water. Still getting some bubbling. James says, so chem wipes are just fancy paper towels. They're chem wipes because they're not just for chemistry, they're for science. But yeah, they're basically fancy paper towels. They're a little nicer than paper towels, and I have them handy. The thing that's mostly nice about them is that they're really strong and don't leave lint. But yeah, they're basically science paper towels. Paul says that's a super common and that's a super common and inexpensive way to check whether or not something is on fire. Oh, by measuring its conductivity. Yeah, I guess so. I've got a heater here that has a pilot light sensor, but I think it's the thermoelectric type where it's actually generating a small voltage. Okay, I've almost got this. Just want to make sure that these are suitably... Yeah, I'm still getting sizzling as I put the vinegar on these contacts. I'm undoubtedly going to end up leaving a little bit of vinegar in there, which I'm going to try to dilute with some of this distilled water, but I assume the vinegar is probably less corrosive than the battery alkaline. It might be worth taking this further apart to make sure it's really dry in there. Alright, I'm gonna mop this up and then swab it with some water and then be done with it. Didn't expect to be taking a detour to fix my Megger, but such is doing things. Oh, gotcha. Vince was asking MakeMK to share the diabolical idea. Yeah, I agree. Dish it out. I mean, I think if you want to do it yourself, though, you don't have to tell us. But if you're not going to actually do it, you should tell us. Aw. Ben says the yak shaving is one of my favorite parts of the streams, though. It makes me feel better when I lose my entire workday to chasing down my own yaks. Yeah. I mean, it does seem to be how these things usually go. I wasn't aware that people would be into seeing it all, you know? Oh, cool. MakerMK is probably going to do a video with their diabolical idea since it involves, or especially since it involves some materials that they have handy. That's cool. Yes, I encourage this. I want to see the results for sure. This one is still a little bit kind of sooty looking with corrosion, but I think it's clean enough. If we're having trouble with that, I might take some sandpaper to it or possibly some more chemicals. But I think I'm ready to try throwing some batteries in here. I'm gonna wait to test it before tossing out the rest of that vinegar solution. I don't have a lot of alkalines, actually. I might have to put rechargeables in there. I don't know how well that Megger works off rechargeables, but I certainly have a lot more rechargeables at the moment. Six. I have a disorganized battery drawer. Okay. Right? Ryan says, introverts unite separately in your own homes. That's what this is all about. I mean, it's also about electronics and cat, but I mean, really, this is what it's all about. I think it's working. Let's put the cover back on and toss this vinegar. Yeah, I don't even know where I should be keeping the battery trash in my shop. I feel like I didn't have a great place for it before. I should put a lid on that so Tuco can't get to it if I'm going to put it low. Sorry. I'm going through my process of trying to find a slightly better place for this than where it was before. I can do that later. Alright. I think these were the little ones. Right? All the reward of socializing with almost none of the social anxiety. That's what we're here for. Do not operate with battery door open. Yeah. I should really screw that all the way shut with the correct screwdriver. Is this one correct? Nope. I'm pretty sure I don't own the right Phillips head screwdriver set. Oh wait, I didn't know I had this. What is this? That's funny. It's a Phillips head hex key, sort of. Okay, that's funny. With less glare, please. Yak banished. Yes, thank you. Cool, so like 85 volts to run this one. The idea behind the beep is it's supposed to be annoyingly beeping anytime there's high voltage at the output, just to let you not to be dumb about it, I guess. Which is good. This thing does produce 1,000 volts. So let's try a few of these lights too. Got a couple of little loose neon bulbs too, which I think are the same as this bag. Oh, IKEA hands out those hex key-ish Phillips head drivers. Neat. I did not know about that. Maybe that's why I have one. So you can see here maybe, if I was zooming in a little more, you could see that it's glowing on the cathode. So, so cathode glow 60 volts, 62 volts now. How similar is this one? 69 volts. 69 volts. We're losing the patient. These are larger. I really like the look of these. They're like great little glass beads. Green. Oh, let's cut some of these without the overhead illumination. Oh, that's really pretty. Oh, that looks really good in real life. Why does it look so bad on the camera? Let me stop this down a few notches. Right? That's so much better. Let's try to show these off without zapping myself too. Yeah. Cathode glow. Oh, let's show this one off too while I'm going. Nice jumpy neon discharge there. Yeah, that's really good. Alright, well, let's turn this back on. I've got to look at my... I've got little marks made with tape that show what the dimmer is supposed to be set to, you know, for consistency. Oh, cool. Nick's got a stack of blue indicators in that little, like, NE2 kind of style. That's pretty neat. I have seen the blue ones. I have one blue one somewhere. I've got a drawer. I have another little stash of neons that I don't currently know where that is, but I'm sure I could find it with a little bit more shop tidying. Okay, well that was a mini tour of some of these neons. There are a few other ways we could light them, like using this little Tesla coil, but I think the thing I'm going to try next is let's just tack down the wires from this high voltage generator onto this, and then try ramping up the voltage very slowly and see what we can get. Aw. Yeah, if it's 3:26 a.m., you should get some sleep, but I'm glad I've been entertaining so far. Jessica suggests that maybe the blue ones were a little bit of mercury vapor, kind of like a CFL or a CCFL bulb. Yeah, it seems like that might have been part of it. I think you can also get a blue glow from argon. If the judges can't tell if it's neon or not, then it's neon. Are you suggesting cheating, sir? Actually, I don't know why I ever use the word sir. I think it's usually annoying. I think in this case it was just for comic effect, but I hope it wasn't bad, sorry. Oh, this wire feels terrible. Like it's insulated with cotton candy. This generator will produce some big sparks, but I'm planning on running it at really low voltage. So I'm hoping we don't get a ton of output voltage. And yeah, my intuition for maybe how to run this is series resistor. I'm a little apprehensive about connecting this thing to any lab equipment because it is like a high voltage generator, but I'm only working on the primary side. I'm thinking, like my intuition here is power supply, series resistor, then like 10x or 100x scope probe just across the input. Seems pretty safe. I might use my other power supply and not my nice Rigol. But Jessica asks if I have a high voltage probe. I have a 100x scope probe. I have like a analog meter that'll do like some kilovolts, but I don't think that'll be necessary here. I'm also tempted to try just sticking a coin cell across this to see what happens. Maybe we'll do that first. Let's get a fresh coin cell. Don't know quite what to expect with this circuit, but whatever. Not much I can do, not much damage I can do with a coin cell, right? Oh, there's a little glow. Yeah. That's nice. It's pretty little too, but it's there, which means maybe my series resistor low voltage power supply oscope thing isn't such a terrible idea. It's moving around really fast. I wonder if it's light sensitive yet. Yeah, I mean, I'm not planning on connecting any kind of probes to the output side of this right now because while the neon acts as voltage regulator, there could be pretty high voltage transients before the neon actually strikes an arc or starts, you know, a glow discharge. Let's try this without the overhead lights. That's just a coin cell. That's pretty neat. Len says, make the largest flashing contraption you can that's powered by one coin cell. That's tempting, isn't it? Of course, I'm wondering if it's already light sensitive. Jessica says it looks like arcing? No, it's glow discharge. It's probably acting a bit weird relative to what we were used to because this is going to be like high frequency AC, whereas it's usually nice and flickery off of 60 hertz. We can maybe look at the other side since I think the glow seemed to prefer the other side. That's not bad for a coin cell. Hearing any interference on the mic when I turn that on? Mako MK says, I think how much damage you can do with the coin cell was a different contest, right? Yeah, Hackaday just recently did one based on what you can do with a coin cell. It's pretty good. Yeah, man. Well, let's hook this up with some actual test equipment. I'm gonna keep things low voltage and high impedance. I'm gonna grab like maybe 100 ohm resistor to put in series with this. I have a lot of 270 ohm resistors. Here's 120. I've got a bunch of these. So this will make it easier to measure the current going into the unit because I can just measure the voltage across this resistor. Oh yeah, Paul's asking about this unit. I didn't actually describe them in a lot of detail. It's like a little potted high voltage power supply module that you can get on eBay. Let me see if I can find a link. Maybe it was AliExpress. I'm not seeing it right away. It's like a high voltage module. It was one of those, like, for a while they were really common on eBay and they were sold with just ridiculous specs. Like you put, I don't know, I forget what input voltage they even are specified for, but they're, you know, they generate sparks like an inch or two long under various conditions. Oh, I think this is it. This looks photoshopped too. It's something like one of these. Yeah, 1000 kilovolt, ultra high voltage pulse generator, blah blah blah. Yeah, it's just like junk like this. Three to 7 volts. So I assume it's just an oscillator and a flyback transformer, and it's potted so that they can reach these voltages, but I don't know what the actual output voltage is on these modules, because this couldn't be right. But they're cheap, and you can apparently use them to run Neon off a coin cell. So yeah, Paul says switch mode and flyback in an epoxy brick. Yeah, I think that's pretty safe to say. So it's going to be generating hella noise, but I think maybe if we run this really gently, we can get a signal off of it on our scope without anything terrible happening. So oh, nice. Nick says they used to sell these things at SparkFun. They're good as like igniters for like flamethrower projects. Yeah, that's cool. Yeah, I mean, we could have fun with this as a spark generator. I just don't want to do that like right at my desk with all the sensitive equipment right next door. So right now I'm endeavoring to not let the output voltage actually get that high. Alright, I'm going to start out with a bench supply set to pretty much 0. And I'm going to just tack this onto the resistor with the soldering iron. Neon's great. I would definitely recommend finding excuses to bring it back. I still see it in art pieces sometimes, like not so much for real signage applications, but for stuff that's like trying to be aesthetic. Okay, so this is hooked up with a series current limiting resistor, 120 ohms, which I'm also using to measure the current. I'm expecting to keep this all pretty low. I'm going to attach a bench supply. I'm going to start it out at like 0. I don't know how low it actually gets when I turn on the output, but I'm going to ramp it up by like 1/10 of a volt at a time, or maybe 1/100th of a volt, I don't know. I'm just going to start off really little. And current limit of 40 milliamps. So that output is on, voltage is set to 0. Let's get the scope running. Okay, here goes nothing. That is connected, and I'm going to very slowly turn up the voltage. I'm at 50 millivolts. 150 millivolts. Still see nothing on the scope. Let's make sure the voltage division is lower. One volt. I'm up to 0.3 volts. 0.5 volts. One volt. I'm going to start going up by tenths. Oh, 1.1 volts, and now we've got oscillation. Alright, I don't see any glow yet. I'm gonna keep going. Whoa. Okay, I backed off because that was growing. Different scale. I've got 1 volt now. Okay. So that stabilizes to... That's interesting. That's basically the same peak to peak as my input. So it looks like we're pretty much shorting out that resistor, and then we can actually see the current building in the flyback transformer pretty clearly. Neat. Do we have any glow? I'm not seeing any glow on the output. Let's go up a little more. Oh, I see a flashing glow. Nice. So turning the voltage up just a little bit increased the duty cycle, or increased the frequency of the flashing. Let's see if this is light sensitive yet. Also, I just wanted to get a better image of the flashing. Have we just built another neon relaxation oscillator? I think we're flashing at about the same frequency on the screen and in real life. I don't think the camera's missing flashes. Alright, I'm going to increase the voltage a little bit. The input is 1.4 volts right now. Can I sync on this? This is 1.5 volts. Oh, it looks like we're not quite fully saturating now. One 1.6, 1.7. Oh, and what is my frequency here? This is 20 microseconds. So 58 kilohertz, it says. That looks right. Great, so now I'm raising this, so So it's almost like the actual AC part of the waveform isn't changing amplitude much, but we've got this DC offset that indicates this extra continuous current consumption. That's interesting. Oh. That's the neon oscillating. Or the neon regulating the oscillation of the input capacitance or something. It would be interesting to see what happens if we put some capacitance in series or in parallel with the input. That would just like give us less signal to work with. Oh, that's cool. I kind of want to try shining a laser at this now. Is that terrible? Let's find those safety glasses. I'm also wondering what happens if I put this inside of a box that protects it from ambient light. Let's maybe do first one, then the other. Shine some laser in the box. I think I've got a cardboard box over here. Alright, let's turn this off for a moment. Alright, I'm tempted to just make a small hole in the lid so that we can like photograph it and then shine a laser in the other side. Let's start with the intact box. Alright, everything's clear. Let's turn that back on. Nice startup waveform too. Don't see any change from just closing the box. Don't see any change. Alright, let's try the laser. I'm not hitting the actual plates in there. I might have to like make a slot just to get this at the right orientation. I can see the faint outline of the laser on... Oh! It's only sensitive on the other side, it seems. Let's flip it over. Paul's wondering if I'm planning on having one bulb as a laser-controlled switch in series with a display bulb. Maybe. I don't know if it's going to be quite that simple, but maybe something where I'm using one bulb as a sensor and one bulb as a display. Okay. Other than blinding the camera, I don't know if that's accomplishing much. Well, I don't know. That looked kind of red, but I don't know if that was just a reflection. I don't know about that. I don't really want to look at it other than through the camera right now. So there's just the paper fluorescing, but then that's the electrode surface. Let's see what it looks like without the voltage. Their power's off. That looks very similar. That might just be the camera. I guess I also meant to look at the O-scope while I was lasering. Oh! I did see some differences in those periods. Let's try this. Horizontal. That was definitely a change in the waveform shape. That. I could sense that. Jessica asks what the power output of the laser. Well, if you believe the sticker, which you really shouldn't, it's under 5 milliwatts. That's about all I know. It's definitely more than that. Yeah, the glow moves to a different part of the tube when I hit it with the laser. It seems like I do need to hit the laser kind of in the vicinity of that area of the plate. Like it doesn't quite work if I hit up at the top. But yeah, I wonder if you could use this, Like, I don't know whether to aim for something that uses one tube or multiple tubes, but it seems like it might be one strategy to, to use some kind of external light, so maybe this laser or maybe something else, to then tweak the frequency of something else which is oscillating independently. Oh, good question. Thomas says try flipping it back over now that I've changed the scope to the super long period. Sure. Oh yeah, a nice startup waveform too. That's cool. I don't see the effect on this side. Oh, maybe in just the right spot on that edge. Okay. Hard to tell if that's reflected off the bulb and then back up, though. Yeah. Interesting. Oh, man. These laser safety glasses are certainly not as bad as the laser, but they're certainly annoying on their own. Yeah, I don't know. Not quite sure which direction to take this in. I like the bulb as a light source. I'm not so much of a fan of this laser, because it's just like very difficult to use safely. Like, I feel like I just need to be worried about reflections every time, and so like operating that in any kind of distance would be a huge annoyance. I think I'd rather stick to something that's like less intrinsically frustrating to use. Ryan says apparently someone's patented laser safety contact lenses. Okay, so a couple of questions here. Thomas says, I still haven't seen the effect. When I had the scope on a smaller period, sometimes the laser made the period so wide it almost looked like it stopped oscillating. I did not see that. I saw it change periods. I think it might have just looked really wide because we were only seeing like 1 or 2 periods of the oscillation on the scope sometimes. I think this view is probably showing more accurately what's actually going on. And then so the scope trace was not on the high voltage side of the transformer at all. I was looking at the voltage across a low side series resistor on the primary of the power supply. Oh, Keith is wondering if I've tried shining a laser through the glasses. Yeah, it blocks most of it. I've tried that experiment before. I don't have like a scientific way of measuring them though, because I don't have a laser power meter. It might be nice to just think about what other light sources. So I mean, I have a UV flashlight here, which isn't that much more eye safe than this laser, but it is somewhat more, and we could try shining it in the same setup. Maybe that's the next thing to do. Alright, I'm going to energize this again. And just to confirm, I don't think this changes when we close the lid. Ah, that definitely changes it too. About the same as the laser, actually. Oh, that's good. Let's get a closer up look at that, actually. We might also do an FFT. So some changes to the shape, but mostly we're changing the frequency. I kind of want to listen to it. What do you think? It does seem like we might get some interesting. I mean, it's like above audio frequencies. But there probably are some low frequency components that would sound interesting. We could also multiply it by like a 50 kilohertz signal. Wait, really? Oh, right, so sorry, I was getting confused because there are multiple periods here that we're looking at. So this is the actual flyback transformer running at 60 kilohertz, which is the thing I was saying was way above audio frequency. But if we zoom out, the actual oscillation period we were seeing, which is the oscillation of the neon bulb lighting and extinguishing, that is very audio frequency. In fact, that's like bass frequency. Yeah, I want to listen to this. I'm gonna get a little speaker. I'm not gonna hook this directly up to the audio interface right now, but just a little standalone speaker might be about my mood. Oh, I thought I had one right over here. When I say a little standalone speaker, I mean actually like an amplified speaker. I was like tidying stuff up in the shop earlier today, and I moved this box with the speaker around several times. Ah, here it is. This actually sounds good. We can hook it up to the actual audio interface through an audio transformer. This is just a little easier right now. Oh, that's a good idea. Paul's asking about a milliamp clamp. I have an oscilloscope clamp meter. I don't know if it's fast enough for this. We might try that just by like wrapping 1 or 2 turns of wire around one of these wires, though. That might give us enough coupling. That's a good idea. Okay, I think, what are my voltages here? Oh yeah, this is fine. This is, I'm gonna, do I need a volume control? I probably want a volume control. The speaker doesn't even have a volume control. Yeah, I would actually just use an aux input, but I just don't have a spare one super handy right now. Maybe I'll grab a different speaker that actually has a volume control. Oh, perfect. I just need this and some alligator clips, and I'm just going to clip this across the resistor, same as the oscilloscope. And these are just some little powered speakers that I'm going to power off of a USB battery pack. these apart, some of these alligator clips. Yeah, that's a really good question. Paul is asking if the high voltage supply is putting out an AC signal or if it's DC. I assumed it was AC, although based on how we're seeing the sensitivity on mostly one side of the bulb, I'm starting to wonder if maybe it's DC. That's one theory. I mean, it could be AC, but we're seeing the difference in sensitivity just because of the physics of like how the current's being conducted through the plates in the bulb. I don't know, like, I'm wondering if maybe the bulb itself could actually have some like weird nonlinear properties that might be affecting this, but so far, yeah, I don't know. I think it's probably safe to assume the power supply is AC, but I'm not 100% there. All right. Contact. Oh yeah, that's our oscillator. How much can we adjust that frequency by changing the voltage? Oh, it goes down to, so that's 2 volts, 2.1 volts, 2.2 volts, 2.3 volts. I'm going back to 2.1. So I can already see how you could maybe divide this frequency down a few times and then have one circuit that uses a GPS clock to measure this frequency and then shine the right amount of ultraviolet light on the bulb to correct it to exactly whatever multiple of 1 hertz you've chosen. That's one way I can imagine this working. Yeah, that's a great set of experiments so far. I think we'll try to follow Paul's suggestion next and try to see if this is AC or DC. So I'm going to put the ultraviolet lights aside and turn off the speakery thing and try just wrapping some wire around one of the output leads. Make ourselves a very simple current transformer and see if that's effective. Yeah, I do have a probe which I think uses a Hall effect, so I don't think it's good at high frequencies. I think it's good for like how much current is my micro using as it's booting, but not so much stuff like this necessarily. Although it looks like maybe some of the frequencies we care about are low enough that it doesn't matter. So, am I gonna see 60 kilohertz at the output too? Seems likely. Could be some harmonic, maybe. Put these aside. Oh man, I feel like just the safety glasses give me a headache. And Tim says, what a horrible waveform. It depends on what you're looking for, I guess. Alright, this is... Let me undo the power lead while I'm handling the output wires. Magnet wire? The magnet wire seems like the right thing for this job, right? don't think I have any on my desk, which is weird because usually I do. .32 gauge. I'm guessing just like thin stuff is probably fine because it would be closer to the center of this wire. I'm just wrapping some turns of this wire around the insulation for one of the output wires, which will give me a very crude current transformer. And I'm going to use the soldering iron to tin this wire a little. And I probably want a shunt resistor across this too. Like a big one, but not just an open circuit. Maybe 100K? I don't know how much good this will actually do, but I don't know, my gut tells me this needs a resistance, otherwise, like, current passes through this coil, and then, given an ideal circuit, you're just letting an infinite voltage build up. Like, you're relying on the impedance of the probe in that case, which does exist, but I don't like relying on that. It's a good way of developing high voltages across your expensive test equipment. So I think I just need to twist this a few times and then do some soldering. How's everyone's Monday going over there? I hope some of you actually do try this, because I recommend trying to flash a light bulb for fun. It's a thing that I have had fun with, and perhaps many of you could have fun with it. And it's really nice finally getting to use the Tuco Flyer camera, even if it's still buggy. It's nice to actually have the functionality that we've got, right? Oh, Len had to wear UV protective glasses. Is that for work, or for making stuff, or because of the sun? Alright, so I'm going to go without the series resistor on the input this time, which means I'm going to start with a much lower voltage. And I'm just going to clip this across the 100K. And do we do this? Trigger. All right. Why am I not getting... Oh, it's just off the bottom of the screen, right. All right, there's my setup. So I'm going to clip on this power supply lead and then slowly turn up the voltage until I see something on the scope or the bulb is lighting. $50 millivolts, or no, half a volt, sorry. Still nothing. 0.7 volts, 0.8, 0.9, 1 volt, 1.1, 1.2, nothing. Oh, I forgot a step. The power supply is still off. I forgot I did that. Okay, and that was the heater. That wasn't me. Okay, ramping up again. 0.1 volts, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 0.9 volts, and we have it lighting. It's actually hitting the 40 milliamp current limit and dropping down to 0.6 volts. So I'm going to slowly ramp up the current limit. It is eating all the current I give it. I'm at 130 milliamps now. I can give it just like 0.2 milliamps. I think the resistor was actually good. I'm leaving it there. It's taking 0.8 volts and 200 milliamps. And do I see anything on here? This is all noise. Mostly. I wonder if it's DC. You know, it might be a voltage multiplier. That would explain the DC output. So that means it's a oscillator, a flyback transformer, and then like some Cockcroft-Walton stages after that, I guess. That would definitely explain why one side seemed to be more sensitive to light than the other. Oh, neat. Tim says the schematic is on the EEV blog forum for these, but they can't post a link. Yeah, that I don't see anything except noise, which I would expect if that output was DC, because any kind of AC output, I would expect that to give me something. So, cool. There might be some uses for high voltage DC, right? It's a shame the polarity on the output is not labeled. Oh, I see, the dentist. Yeah, that's not so great either. Oh, and the vacuum chamber and their camera's leaking. That doesn't sound good either. Every so often I hear the spool pigs make some piggy, squealy noises, which is funny. Like right there. Well, I feel like we're wrapping up maybe what might be like a first kind of investigational pass at this. Just like what can we do with some of the pieces here. We can definitely use these as a light sensor for UV light. I guess I did not try other wavelengths of light sources. I don't know if that's something I feel like doing right at this moment. I demoed those other two lasers I have on the video I posted last year. Yeah, tubes and Jacob's ladders and ion fans, yeah. Why do you, actually, that's a good question. Why do you want Jacob's ladder to be DC? Is that just because AC would cause the arc to restart? Could you run a Jacob's ladder on high frequency AC? Or would that just have too much corona? Oh, interesting. Thomas says that when I was running it off the coin cell, it was constant, and can I still sense the UV when it's not flickering? That's an interesting question. I think we can try to answer that. Okay, well, power supply disconnected. Just taking the experimental resistors off. Okay. So the thing we were doing before with the coin cell, let's just replicate that. Yeah, that does seem to light solidly, doesn't it? That might just be because the voltage is higher. Yeah, I could try just putting the scope across the inputs here. I think I do need to solder that to something longer. Might even help to have a real battery case for this. Pig is making adjusty noises. Let's move it down a little bit. So many people with vacuum projects. Is that the new hobby? It's like instead of building muscle cars, people have a vacuum chamber. I mean, I realize this particular comment, that was probably for work, but I see this a lot on YouTube at least. There seems to be a growing number of people who are interested in vacuum electronics and vacuum physics. Okay, Tim says Jacob ladders are usually AC. That's what I thought. I thought people used to make, or usually make them off of like neon sign transformers. Alright, that is the scope. Oh, pardon my leaky nose. Bad allergy month or something. I don't know when this actually started. Maybe I'm actually coming down with a cold. I gotta keep checking the polarity on these. Okay, plus is on the side. Minus is on the top. Let's try this out. Not 20 millivolts. A couple of volts there. Oh, that's cool. Yeah, I'm gonna, whoops, sorry I keep bumping that. I'm gonna see if I can ever have a real, like, coin cell holder somewhere. I'm pretty sure I do. The trick is I don't know if I have it somewhere where it's easy to find right now. Yeah, it's not really worth searching for that right now. I'll find that later. Alright, makeshift battery holder over here. I assumed this would not be conductive, but maybe it is. That's better. Now I'm wondering if that settling is because the battery is discharging. Whoa, look at that spread spectrum. Now we're all the way at 130 kilohertz. And wow. Gosh, I would love to frequency demodulate this right now. It looks like there's a ramp pattern in the modulated signal. We can try different ways of extracting signals from this, but I just want to hit this with some light and see what happens. I did not see that change, but maybe we're not looking at it right. Huh. Is this one of those auditory illusions where the tone that continuously rises? This is so weird. I thought I just heard it oscillating. I don't see the glow discharge anymore. I'm guessing that we're just rapidly discharging this coin cell at this point. Is this warm? Coin cell is not noticeably warm. Oh yeah. Some electrochemical action there. Yeah, I'm thinking that we're seeing the different behavior with the steady state just because now the current is high enough. Well, I don't know if it's about the current actually. I mean, it's probably just the voltage at the output isn't hanging out in that region where the hysteresis, or where it like may or may not light depending on the incident light. Okay, we've got that bump kind of moving around. Yeah, that's not super conclusive to me, but interesting at least. Oh, that's a great idea. Jessica says, I bet a software-defined radio with a down converter might show all kinds of excitement. Yeah. Tim's like, oh, you know the YouTube cycle. First it's red hot nickel balls, then hydraulic presses, then red hot knives, now bell jars and blenders. Yeah. Yeah. Yeah, we could try sticking an RTL SDR on this thing. I think I've got one of those over here. Quick, what's your favorite RTL SDR software? So now I'm having trouble remembering which platform I was using this on last. Which platform is GQRX for? Oh, cool, it's cross-platform. Oh, and I can grab it with Homebrew. Well, that's great. Next question, where do I plug this in? To a USB hub. Let's just try this. Huh, RTL power, integrate over the entire receive spectrum. For, I guess I'm not quite seeing the point. RTL power from 20. Oh, that's a tool for logging a spectrogram? Oh, that's in Cask. Is RTL power part of some other distribution I should have? Is that, I assume that's not part of GNU Radio due to the RTL prefix. Oh, okay, that's just part of the normal tools bundle with RTL SDR. This is the lib. Oh, I guess I already have it. Cool. When did I install those? Who knows? Well, let's try GQRX first to see if we have this set up right. This doesn't seem happy. Oh, there we go. I just have to press play. And it's like underflow, overflow, whatever. Cool. I mean, I guess I have used this program before. It's just been a while and I didn't really use it in that much detail. Wait, so why? That's interesting. I don't understand why. I thought this was tuning. Oh no, so that's tuning. That's tuning. This is not tuning. That's a little weird. This is just changing how the graph is aligned. Anyway, we could just try turning this on and see if there's any noise that seems to be correlated with it. I'm not quite sure how low it's useful to go on the RTL SDR. I don't know. It might be kind of broadband. We'll see. Yeah, we could definitely bring out a fancier software-defined radio here, but the RTL SDR dongles are easy, so it's a nice first place to go. What if I just touch this to the battery? What is the scope telling me that is now? That's like 120 kilohertz and jumping all around. Maybe I can find some harmonic. I am touching this to the battery with a period of about 1 hertz, or maybe a couple hertz. I'm just I was just kind of curious if I would see any just broadband garbage that appears and disappears at that same rate. Maybe not. Maybe it doesn't pollute as much as I feared it would. There's some actual signals here. Jessica says the number on the right side is the offset for the demodulator section. Oh, are you suggesting that maybe we try to get the data in through the IF? This is kind of fun in a pointless way, but I don't think we're going to get the signal we want just from searching through like this. We probably have to calculate a relevant harmonic frequency or use a different tool. I have a couple of other tools that might work out here, but I don't know if this is the right time to bring those out. I think I might just wrap the stream up in a sec and think about what to do next. So far I'm not noticing anything that's correlated with my tapping. Got some interesting radio frequencies though. It was a good try. We could do some more with SDRs, maybe in a slightly different setup here. Anyway, I think unless anyone else has some last minute suggestions, I think I'm about out of ideas here for the current stream. Oh, and the card's full. So maybe that's a sign that I should wrap this one up for the moment. But yeah, thanks for stopping by. I hope that was kind of interesting. It was a bit different than what we usually do, but I hope some of you might be inspired to try flashing a neon light in a strange way. I especially hope some of you are inspired by the weird old school neon lamp logic and all that we were looking at. So yeah, thanks for hanging out, and I hope your projects go well, and as always, thanks for stopping by, and thanks for telling your friends about the channel, or sending a couple bucks my way with Patreon, or any of the other ways that you support the channel if you do. And if you're new here, well, maybe check out some of the other video blogs I've posted on scanlime.org. I try to kind of pack as much information into those as I can and summarize the work so far, so they don't come out super often, but I try to make them worthwhile when they do. Oh yeah, SD Swartz recommends getting a HF to VHF up converter. Yeah, I've gotten close to getting some kind of up converter for my RTL SDR in the past and haven't quite actually taken that plunge. But there are various ways we can get this analog signal into something. I think one direction would be the SDR, but another direction might just be to analyze this on some kind of microcontroller or use the audio directly. So, and maybe some kind of closed loop. Well, and thanks for stopping by. I'll see you folks next time. Happy hacking, everyone.